Okay. Good morning, everybody. This is Dana Fisher with Mitsubishi Electric. This is a webinar training on integrated controls, prompted specifically by incorporation of integrated controls measures into the New York State Clean Heat Program for two utilities, Orange and Rockland, as well as in Con Edison territory. I'm not really going to go in depth into the incentive levels associated with the variety of utilities across New York, but suffice to say that the incentive levels in those two territories are quite elevated. So for both in O&R territory, which is sort of mostly on the west side of the Hudson, just north of the city, it's $2,400 per 10,000 BTUs of capacity at 5 degrees Fahrenheit, where integrated controls or decommissioning of the system is incorporated. And then in Con Ed territory, it's $3,500 per 10,000 BTUs at 5 degrees Fahrenheit capacity for integrated controls, and $5,000 for decommissioning. And if it's in the gas constrained area, which extends for a big chunk of Westchester County from pretty much the Bronx to a number of clicks north of White Plains, you're talking about $5,000 for integrated controls per 10,000 BTUs. No, I'm sorry, take that back. $4,500 per 10,000 BTUs of capacity at 5 degrees Fahrenheit for integrated controls. And if it's decommissioned, it's $6,500 per 10,000 BTUs at 5 degrees Fahrenheit. So rapid fire on that. As I mentioned, I really don't want to delve into that too much. I have started circulating a calculator similar to the one that Clean Heat developed early on, that incorporates all of Mitsubishi's equipment and allows for an easier calculation to verify that you've got a match between your manual J, manual S, and the product selection that you've made. I've been going back and forth with ICF to make a couple of little tweaks to it to make sure that it's perfectly accurate in all iterations. But as you can imagine, there's a lot of different ways that can go sideways. So I anticipate that being in a final version and distributed with the latest and greatest probably by the beginning of next week. Okay, so without any further ado or introductions or whatever, I will jump directly to share my screen and look at the integrated controls slide deck that I have here. Let's see if it's not really, looks like you guys are looking at, okay. So can I get confirmation? Are you guys seeing the first part of this slide deck?
Yes.
Okay.
I can see it.
Thanks, Andy. Glad to have you aboard this morning.
4 and 5? Yes. Yeah, 6.
Okay, super. Great. So I'm going to dive right into it. So integrated controls, what are we talking about here? Integrated controls is where you have a single point of thermostat control for a consumer, where they're going to be able to adjust the temperature for that zone. Could be, if it's a zone, if it's the whole house, okay, it's all ducted, all right, one control point. If it's multiple zones, okay, there are multiple thermostats or control points. But that one control point controls both a primary source of heat and a secondary source of heat. In the case of integrated controls with heat pumps, and where programs are interested in having them, you're talking about using the heat pump as the primary source of heat, and then having a secondary or backup source of heat that is triggered through one of a couple of different strategies if and when needed. And we're going to talk about those strategies in detail and how they apply. Now, why do utilities want to use these kinds of things? Well, what studies have shown over the last several years, when evaluators go out after the programs have been doling out rebates for some period of time, they go out and they evaluate the results of the program. And one of the findings that they've uncovered in a number of these different evaluations over the years is that consumers don't use heat pumps as much as program administrators would like. And so they're not generating the energy savings that the programs are counting on in order to justify their rebates. So you can't have a rebate program if you can't demonstrate the energy savings. And so in order to rectify this gap between what would be possible to displace with heat pumps with what's actually happening with consumers, one of the concepts is to incorporate integrated controls so that you get a first stage of heat, and then you get a second stage, and it's all through one control. I think, at least the way that I think about it, I think a lot of times what happens with consumers is if they have separate controls, particularly if you've got a remote for the wall mount unit, for instance, on a ductless unit, is they may use the ductless unit for a while, and then it gets cold, and either they've heard from friends, neighbors, or one of the installers that they should turn it off at a cold temperature. They'll shut it off, and they'll use their conventional heating system for the rest of the year, or they get one super cold day in December or something like that, and they say, oh, well, that's it for the heat pump, I'm going to use my conventional heating system, and they don't get the benefits. Some portion of the population doesn't turn it back on, and they don't get the benefits of using the heat pump throughout the entire season. And so by having integrated controls and having one point for all of your heating and cooling, you eliminate that possibility of human error in eliminating the use of heat pumps and increasing that usage. So that's the whole goal and idea behind integrated controls. And of course, when programs like Massachusetts or New York are promoting this, they're providing hefty incentives. And so that's why we're having this conversation: is how do we comply with this? How do we incorporate integrated controls? And how do we do it in such a way that our clients, the end users, will be comfortable and get the energy savings that they're expecting? So a couple of keynotes before we get too far into this. I always want to mention this because sometimes people remain skeptical about this, not only in the public but also in the contractor base. And I want to assure you that if you're selecting heat pumps and you're matching the capacity of heat pumps at the design load for your location, whatever that design load is, whatever temperature it is, that is the appropriate design load for that location and the amount of heat load. If you match that to the heat pumps, they can displace 100% of the heating load for that home. And that is absolutely positively the case in New York, particularly down in like Westchester County, where it's relatively warm to northern New England. There are homes and contractors in far northern Maine that haven't used fossil fuels in years and just depend on heat pumps. You may not be able to accomplish everything you're seeking to do with one heat pump, one outdoor unit. You may need to have multiple outdoor units depending on the heating load and the geography, the sort of the layout of the house. So definitely things to keep in mind, but I just want to emphasize, like, people should have complete confidence in the ability of appropriately sized cold climate heat pumps to displace as much as, if not more, than 100% of the heating needs of any individual building, whether it's weatherized or not. It's a matter of matching the load to the equipment. Okay, so the other key thing, and I'll come back to this at the end of the slide deck, when you're doing integrated controls, one of the most important things is to make sure that you understand the interaction of not only you understand the coverage of the heat pump zones, but you also take into consideration what the coverage of the conventional zones are and how those are either aligned or different, because that's something that you're going to want to look at. If you have zones that are different, meaning like you've got parts of the house that don't have coverage from ductless heat pumps, but they do have coverage from conventional heating systems, there may be points in the winter when those extraneous parts of the house, those far distant parts of the house, get much colder. And people will be like, well, it's really cold up there, the heat pump isn't heating that section. That may be an appropriate place to say, you know what, we need to separate that portion of the conventional system out so that can be controlled independently from what's going on with the heat pump. Okay, that's one example, and we'll go over a couple of different ones, but that's the kind of thing you're going to need to think about. Okay, and the last point is that sometimes people get fixated on economic balance point. And this is something that varies every time there's a change in the price of commodities, so when the price of gas or the price of oil goes up or down, it changes the economic balance point. And so the economic balance point is the temperature at which it is the break even, it's the same at the temperature at which it is exactly the same price to operate a fossil fuel system versus a heat pump. Above that temperature, a heat pump is going to be more inexpensive to operate, and below that, it's slightly incrementally more expensive to operate than a conventional heating system. And so some people will get fixated on this economic balance point and be like, I've got to have it switch over at that economic balance point because that's when people start saving money, and I've got to make sure that people are saving money. But the reality is that the amount of savings that occurs is so small, and it's highly variable depending on what's going on with commodities, that this, and we've got a couple of folks from Efficiency Maine on the call here right now, that when, and they did a study on this economic balance point. And so like, at least in Maine, where, okay, granted, electricity is cheaper than it is in New York State, for instance, or in Massachusetts, the economic balance point was around 0 degrees against an oil-fired boiler. And if you were to switch perfectly on that economic balance point, you would save some handful of dollars, $4 or $5 per year, by switching between the two. And so it's not very much. And so in other areas, or where you have natural gas heat, for instance, which is relatively low per BTU, you might get a greater economic benefit by switching over, but it's still not that big a deal. It's just not that big a deal. And what is a big deal is that when you swap over on an economic balance point temperature, there's a greater likelihood that you'll generate discomfort in the home. There will be colder conditions in between that transition between the heating systems. And if it's at a point where it's a pretty common temperature that you might swing through in the course of the day, and so part of the day you might have one heating system, part of the day you have the other heating system, you're going to get a lot of complaints from consumers. And so, like, I want to just encourage people to avoid using a balance point, or even really bringing it into the conversation, because the amount of savings that would be generated by having a highly accurate economic balance point does not displace the benefits of just having a consistent comfort throughout the home. Okay, so let's talk about integrated control strategies. There's really two strategies, and these are highlighted very well in the guidance that came out in New York State. One of them is a switchover based on outdoor temperature, and the other one is a droop strategy. And so in the New York State example, you can use one strategy or both strategies, either one, either or. And in Massachusetts, early on, they started out advocating for sort of a combination of strategies, but you had to, they recommended having a switchover temperature relatively warm. And honestly, we've seen examples in Massachusetts where that just caused a real big problems for consumers. And we're anticipating that our understanding is that there are some evaluations coming out anytime now or about integrated controls programs in Massachusetts, and we'll see what the outcomes that they find there are. But I'm anticipating that one of the things that they're going to uncover is difficulties associated with the switchover based outdoor temperature strategy. Okay, so just broadly, the switchover based on outdoor temperature is where you say, as you can see in this little box up in the top right-hand corner, and I'm a old, I learned how to program in BASIC on Apple IICs back in the early 80s, and so I always kind of think of things logically in terms of Apple code, and of course, I'd have the different line numbers there. Yeah, super geek. But so it's basically levels of logic, right? So the first command is, hey, if the outdoor temperature is above whatever your set point temperature is, and in this example I have 17 degrees, just use the heat pump. And then if the temperature drops below that magical temperature, just use the backup heating system, right? And then just repeat that cycle. And it just looks at the outdoor temperature and it looks at that. Now, that might be fine if but I mean, like, there's a couple of assumptions there. Like, how did you pick that magic temperature? You know, how much time as the installing technician did you do to assess what the appropriate temperature was for that switchover? Could there be circumstances where it's exceptionally windy and you have a high, you know, I'm losing it. You know, the heating degree is higher because of the wind factor. And so, you know, the load on the building is greater. You know, maybe 17 degrees isn't the right level. Or what if it's a really sunny day? It might be 17 degrees out, but it's really sunny. And so the windows on the south side are going to generate heat, and you don't really need to have the backup heating system switch over entirely. I mean, there's just sort of like a lot of environmental variables around that for selecting that temperature, and you don't really know whether it's going to be needed or not. Okay, so then the droop strategy is where you've got the heat pump running, and if there's any circumstance where the heat pump is unable to keep up for a particular period of time, and different systems are going to have different sort of variables set into this, like a specific droop amount, like how low below a set point it is, and how long it's below that set point that the system senses that it's unable to keep up before it triggers that backup to come on. And then when the backup comes on, it's in addition to the heat pump. So the heat pump's operating, it says, oh my gosh, I'm not able to keep up. It sends out a signal, bring in the cavalry, backup heating system of any nature, whether it's hydronic or electric or whatever, comes on, brings the temperature of the space up to the set point, and then shuts off the backup heating source and says, hey, I'll call you when I need you. Again, sometime I'm just going to keep trucking, right? The heat pump's just going to keep operating. So that's the droop strategy, okay? So pros and cons. Switch over based on outdoor temperature. You know, this is one of those things where if you've got a house where you don't have complete coverage by the heat pump zones, you may, the only reasonable way may be to say, you know, once I get below a certain temperature, the sort of the ballooning out of warm air from centrally sourced ducted heat pumps is just, it's insufficient to overcome the force of cooling that may happen on extremities of the house. And that's where we would need to just say, okay, below this temperature, we need to switch over and use a conventional heating system because of the distribution categories going on there. Okay, and so, you know, and you could use a switchover temperature based on an economic balance point, as we already started to discuss, in order to provide some additional economic benefit. But even in the case of, you know, natural gas across this entire region, across the entire Northeast, the benefit of switching over and having perfect switching for natural gas, the maximum would be something around the ballpark of 5% seasonal savings. It's really not that great of a savings, even against the cheapest fuel. It's always cheaper to just run a heat pump against propane, and 99% of the time it's cheaper to run against oil. So, like, I'd be careful about that. So the cons, the reasons why switchover may not be totally great. One of them is comfort, right? And I'll get into some real close detail when we get to the end of the slide deck about an example of Massachusetts. But when you're switching between heating systems, there's sort of a lag in the period of time it takes for a system to deliver heat. You know, when you turn on a conventional heating system, the pipes or the radiant or whatever the delivery means is, takes a little while to catch up. And so, you know, depending on that switchover temperature, you can have a comfort lag there. And that will give people the impression that there's something wrong with the system. It doesn't matter how well you describe it to one person or two people, but after a year or two, they're going to forget it. They're going to be like, oh my gosh, this heating system is really weird. We get this kind of change. Then all of a sudden, you know, we get below a certain temperature and the heat pump doesn't work. Apparently, they would think heat pumps don't work below that temperature because they'll forget that it's actually programmed into the system to have that swap over. So, you know, not only do you create a real sensible comfort problem, but you also create this impression that heat pumps don't operate at colder temperatures, even while it's just the strategy that's employed for integrated controls. Okay, so it's a little bit tricky, and you can create some cycling, and you can cause humans to do strange things like use electric resistance heaters and drag them around your house, in order to overcome the fact that they have this system that's sort of arbitrarily switching based on an outdoor reading. Okay, droop strategy is, as I described, you can see in this little figure up here. There's you're at set point when it's at 0, and if you have the temperature drop a couple of degrees below set point for some period of time, 10-15 minutes, depending on the settings of the system typically, it'll kick on the backup heating system, which brings up the temperature to the set point and shuts off and allows the heat pump to resume within whatever range. And if the heat pump ever needs help again, it'll call back. Okay, so in New York State, where you're sizing everything to at least 100% capacity in order to use the integrated controls, you may never have the heat pump backup kick on because you're sizing it to 100%. And let me tell you, manual J is conservative by double-digit figures, and manufacturers, including Mitsubishi, are pretty conservative about their heating capacity ratings. And so there's a high likelihood that if you have done a reasonably good job of getting in the right ballpark with your manual J calculation, and reasonably good job of using manual S to select your equipment to size it to the peak design load, you're probably never going to need that backup, but it's there just to provide people with that comfort. You may have noticed an earlier slide, I had a little picture of a feather that's representative of sort of Dumbo's feather, in order to fly. That's how I think of backup heat sources when you properly size your equipment. People are nervous about that with heat pumps because it's such a new technology to us, even though it's been done like this all over the world for a long, long time. So just having that backup heat in the integrated controls is sort of like, I'm not worried because I've got the backup heat. But the reality is you probably just don't need any backup heat at all. Okay, so the con, as I've mentioned already a couple of times, is if you have a dramatic mismatch in the zones between the ductless distribution and the conventional zones, droop is not going to do a particularly good job without having some separately controlled zones. And that could be like, if people didn't have a well-insulated or well air-sealed basement, and they didn't have a heat pump in the basement, and they previously had a boiler down there and they were keeping it warm, and they were concerned about, the basement freezing or something along those lines. Okay, this may be a circumstance where in the course of the installation of the heat pumps, you would look at that zone, or it could be a remote distant bedroom, and you say, we're going to put in or modify the existing zones in order to provide heat to this area, and we're going to have a separate thermostat that's independent of what's going on with the integrated controls of the ductless heat pump and conventional heating system for this particular area because of the distribution differences. Okay, that's sort of the best approach. In like your basement, you might set that zone to 40 degrees and say, I just want to make sure that, it's never going to get below freezing in the basement because that's where the plumbing is, and they really could use some air sealing and insulation, and that's what my recommendation is, but they're not moving, the client isn't moving ahead with that kind of a project, so I'm going to cover my bases. That's an example, but definitely sort of an extreme, just something to keep in mind when you're considering different systems. So for Massachusetts, for New York State, and a number of other places where integrated controls are required, there are a number of systems that satisfy the program criteria for either strategy, frankly. And for Mitsubishi, right, because we're talking about Mitsubishi equipment here, there are really 6 options, 5 of which are supported through Mitsubishi, and then sort of an other category that can work. And we're aware of those, but I can't say that we've tested it, and you certainly wouldn't get support for it if you called our customer care hotline. So number 1, Kumo station, right? It ties into our Wi-Fi phone app and has 4 dry contacts in it. All of the relays in the station must connect or correlate to a Mitsubishi indoor unit. So as long as you have a reasonably good match of indoor units to conventional heating zones or humidifiers, dehumidifiers, Kumo station works great. It cannot control zones independent of Mitsubishi indoor units because the Mitsubishi indoor unit or a connected thermostat is the source of sensing the temperature for the room. Number two, and I'm going to go through all of these very quickly here and then in greater detail in coming slides. And we're about 25 minutes in, so we've got a little bit of time, but I'm going to keep up at this rapid pace, so hold on. Okay, so number two, thermostat interface, right? So Mitsubishi has, and other manufacturers too, have thermostat interfaces. Our thermostat interface plugs into our communication port, the CN105. And then there's a series of dip switches on the inside of that you can adjust. And it has connectors, standard thermostat connectors, W's and Y's and R's. And you would run your standard thermostat wire to whatever your favorite flavor of dual stage thermostat is, and use presumably the existing thermostat connections going down to whatever zone, and that could be for a central system for the entire house, or it could be, for multiple thermostats throughout the house. A lot of different options there. If you've got a client that's like, I love my Nest, I've got to use a Nest thermostat or Ecobee. Okay, great. It's two-stage thermostat. You'll be able to manage the whole thing. They'll be able to continue to use what they're used to adjusting, and it'll give them the performance out of the heat pump first, and then use the backup system later, and you can adjust the settings within those thermostats. Third option is a CN24 relay kit. Most of our equipment, with some exceptions, have a CN24 port on the control board of the indoor unit. It's 2 pins, and anytime that the systems need to call in the cavalry, and this happens whether you connect something to it or not, all the systems that you've installed, that meet these criteria, they have those 2 pins. Those 2 pins light up with 12 volts DC, 0.1 amps, anytime that it's unable to keep up. And if you were to connect a relay kit to it, which is really just a low voltage relay, you could call in the cavalry using that signal and just turn on whatever zone using basically a run of thermostat wires. I'll get into greater details on that, but that's a very simple, very low cost, and effectively bulletproof method for controlling backup heat to zones. Okay, fourth item is AirZone. AirZone is a third-party control a suite of products that have the ability to communicate with different manufacturer systems. We have our little communicator board series that plugs into and is sold as a Mitsubishi product with AirZone. AirZone, when I think what was really primarily introduced as an option for controls with Mitsubishi to allow for dampered ducts to be able to control zones, ducted zones. And it does that very, very well. And you can control up to 10 zones, whether they're ducted or dampers or radiant heat. It can manage all different kinds of heat sources. And it also has a module that has up to 5 dry contact relays, and you can use 2 of them to cover up to 10 backup zones for a system. So it's a pretty expensive system, but it gives you an enormous amount of flexibility for a very large system. So if you have very high incentives or and demanding clients, AirZone can be a great solution for very complicated integration solutions. Number 5, IFTTT, otherwise referred to as IFT integration. Our Kumo Cloud app does communicate with IFT. And IFT is an online platform that basically serves as a hub for a gazillion different Internet of Things devices, everything from outlets to lights to thermostat sensors to thermostats. And so you can integrate different Internet of Things. So it's sort of IFT stands for if this, then that. So you can set it up so that, like, if the temperature at this weather station drops below this temperature, I'm going to turn on this backup heat source and adjust the temperature on the Mitsubishi off. So I mean, like, that's the kind of thing. Here again, I'll have some additional slides on that. I would really recommend that only in circumstances where the homeowner is really pretty techy, and is gearing for this kind of whole home, smart home integration. It works, it qualifies for the integrated controls incentives. It's less stuff than some of the other options, but it requires having an IFT account. It requires connecting those two systems in such a way that they integrate and have appropriate logic in them to operate properly. You know, it's a pretty geeky approach. Other ways of approaching it, we know that one of the more popular methods for doing integrated controls in Massachusetts, particularly when it's not a Mitsubishi equipment that has all these other options, is a Flare Puck Pro, which uses the same IR communication methodology as remote control to communicate with indoor units. And so one approved pathway for doing integrated controls is to use a Flare Puck Pro system, where you have an indoor unit in each one of the rooms, where you would have a ductless unit, and you also have a hub controller thermostat that would turn on the conventional heating system, and you can configure it to via your phone app or the thermostat that's in place to set the temperature for the heat pumps using that IR signal, and then also communicate to turn on your conventional heating system if ever required, or set to an outdoor temperature depending on how you want to configure it. Okay, so so I guess I'll pause just briefly there. Are there any, and I'll go back to that summary slide before we dive into details on the individual ones. Are there any questions at this point in time, or things that people want me to kind of double up on before we really get into some of the details on these different options? Okay, well, being the guy I am, I'll take that as a positive sign. I know I'm throwing a lot of information at you, and I'm sure that it's all just delightful, right? Okay, so with that being said, the basis of any of the Kumo options, whether you're talking about IFTTT or using a Kumo station, one of the core things that would need to be incorporated into the system is a Kumo adapter for each one of the indoor units. Okay, and the Kumo adapter, it's like a large pack of gum size adapter and a 3-foot or so cord dongle that plugs into the CM105 port of any of our indoor units. It also has a little piggyback port on it, another CN105 connector on it. So if you wanted to connect one of our wireless thermostats, an MHK2, you could piggyback the MHK2 adapter receiver onto the back of the Kumo, and then wirelessly install the MHK2 to sense temperature on the other side of the room and allow in-room modification of the temperature without resorting to a phone. Okay, at this point in time, the Kumo adapter only works with 2.4 gigahertz wireless signals. A lot of new modems have both a 2.4 gigahertz and 5 gigahertz band. So when you're setting it up, you need to make sure that the technician's phone is only connected to that 2.4 gigahertz zone, and that you're only connecting it to the zone and the password, the channel that's associated with that 2.4 gigahertz band. And then, once your phone's connected, you basically communicate with the adapter via Bluetooth on your phone to configure the system and tell it what the Wi-Fi password is so that it can connect to the Wi-Fi independently. And then once you have all of the indoor units, or whatever indoor units are going to be connected, installed, then you would also install, you would either adjust it in the advanced settings to communicate with IFTTT, or you would set it up with a Kumo station, which serves as sort of like an accessory component to a Kumo installation. Okay, so the Kumo station is really, it's not very big. It's kind of like a kid's shoebox size. It's just a metal enclosure with 4 switches on it. And typically it's mounted in the basement, like in a utility room or, next to the boiler or your different zones. And it operates on 24-volt AC. So you got to have a transformer providing power to it. And then it's got 4 dry contacts in it. 2 of them can be set as wet contacts if you'd like. But generally, those 4 contacts can be used to control and turn on humidifiers or dehumidifiers, or in the Northeast, more commonly, multiple zones of heat, like radiant. So or hydronic baseboard, just by turning on zone valves or pumps, that sort of thing. Okay, and there are other accessories associated with it. So you have these Bluetooth wireless remotes that sense both temperature and humidity. That should be included for every zone that you plan to control. And it's not only because you get a better room temperature for the heat pump aspect of it, but it also allows you to place that sensor, that temperature sensor, somewhere in the room where it's going to be both a good place to sense the temperature for the indoor unit, but also an excellent location to sense the temperature for your backup heat source. And so the sort of the illustration of that is, if you didn't have this sensor and you were sensing the temperature of the room from the wall mount unit, and your baseboard on the other side of the room comes on serve as a backup, well, you might cook the other side of the room by the time your heat pump realizes what the temperature of the room is. So by being able to have that remote sensor and park it where it's sort of balanced to measure an appropriate room temperature where it's going to be comfortable for people, you'll get the best of both worlds. So that same principle applies whether you're talking about this wireless Bluetooth remote or whether you're talking about the placement of any other thermostat to do this measurement for 2 stages. It's really, really important to make sure that whatever is going to be measuring the temperature for a room to control temperature in that room has to be appropriately placed for either distribution system. Okay. Then down in the bottom right-hand corner is the outdoor temperature sensor. It comes with, like 60 feet of wire, and you just, park it outside on north side of the house, so it's not getting a false reading from whatever's going on with the sun, or not going on with the sun. Okay. It can be connected directly to an indoor unit, and the prime example of pattern 2 where it's directly connected to an indoor unit using the CN105 port is where you're tying it into a furnace, and you're controlling a furnace, and maybe or an air handler, and so maybe you have that next to a furnace and they're kind of going through one another for backup. There's a bunch of other strategies, but like that's pretty common. I don't think that's going to be common with integrated controls, but that's a strategy that is normally the case if somebody wants Kumo, but they're tying into a piece of equipment that's directly next to them. Okay, and just to sort of demystify the wiring that's inside of the Kumo station, there's really only 4 things that get connected to it. So you can see I've highlighted here a 24-volt AC transformer. That's power for the box. Then next to that is a set of the channel pairs for your connections to the 4 dry contacts. And then you've got a connector port for your wireless interface, your Kumo adapter. And then if you were going to connect it to an indoor unit, you would connect from the CN105 port of the indoor unit to this CN460 port on the Kumo station. That's sort of optional. I don't see that used in most applications. And then there's a 2-wire connector for the outdoor temperature sensor thermistor. Okay. And all of this is detailed as everything else that Mitsubishi does in our incredible website, www.mylinkdrive.com, my favorite website on the entire interweb. Okay, so then the next option, right? Third-party thermostat interface, are delightfully labeled PAC-US444CN-1. This allows you to integrate any one of any thermostat, pretty much everything from the old-fashioned Honeywell round all the way to Nest and beyond. If you don't have 24-volt AC in the house already, you will need a 24-volt AC transformer to go through. Typically, you're going to have that on site if there's already a conventional heating system. And you can see that the clamshell here kind of it opens up, and that's where the dip switches are. There's one dip switch in particular that I really want to bring your attention to, and it's this 2-6. When the thermostat interface comes from factory, all of these dip switches are off. And in 99% of the cases, you're going to turn on this dip switch 2-6. That one basically allows the Mitsubishi system to operate using its variable speed algorithm. If it remains off as it is from factory, then anytime the thermostat interface says, I've got a call for heating, it's just going to go to full speed. And as soon as the heating call stops, it's going to shut off the system. And that's, I mean, like, will it work? Absolutely. May it be appropriate for ducted solutions? It might be appropriate for ducted solutions depending on the layout of the ductwork and what's going on and what you're trying to accomplish. But most of the time, when you're doing a third-party thermostat interface, you're going to want to have 2-6 on so that the Mitsubishi equipment can modulate and match the temperature and provide all of the efficiency through its controls that you would expect out of Mitsubishi equipment. Okay. The other control switch, switch 1, has 4 dip switches. And what I've highlighted here or included on this slide are recommendations for setting the system up in areas where there's a high latent load, high moisture content, high humidity in those areas, like Southern New York. So, and there's an app note related to this, and I've put the link down here at the bottom, but you can find it on my favorite website, www.mylinkdrive.com. In the app notes section under controls, there's a note specifically about using the third-party thermostat in high latent areas. And frankly, this diagram and similar instructions on how to configure it are all laid out in the instruction manual, the exhaustively well-detailed installation manual for the third-party thermostat. And so you can see these kinds of wiring diagrams and pick the one that's most appropriate for the application that you're using. And so when you're using this third-party thermostat interface to do integrated controls, you're basically just making a dual fuel thermostat, right? You're saying heat pump first, conventional heating system back second, and within the controls of your thermostat, whether it's a Nest or an Ecobee or whatever, or Honeywell, inside of the controls of that thermostat is where you would adjust and set the droop or the outside temperature or whatever else. My strong recommendation is just to set up a droop temperature of a couple of degrees and a delay of 10 or 15 minutes, something like that. That way there's not a big comfort threshold before it turns on. People won't even notice it, but you're going to continue to use the heat pump throughout the entire cycle and season. Okay, a little bit closer up picture of the CN24 relay kit. There's not much to this. The secret sauce of this is really that it's got plugs that fit directly onto the control panel of the indoor unit and go right to the CN24 port. The other end of the wires are just your standard electrical connectors to plug into a low voltage relay that comes with the kit. So you're plugging into, you're going to deliver anytime that there's a call for the cavalry, you're going to deliver a 12 volt DC 0.1 amp signal to that relay. It closes the contacts, and you would just run, probably in most cases, 24 volt AC through thermostat wire, bridges that gap, closes that circuit, off you go to a zone valve or something like that. So you'd have your transformer run 24 volt AC across that relay on the back end, and then go back to a zone valve or a pump or a boiler trigger, same as any thermostat. And that way, if you use this strategy, I'd probably put an MHK2 again to measure temperature accurately and give somebody a nice wall thermostat to manage. And they'd be able to turn up and down the temperature to control the temperature. And anytime the heat pump was unable to keep up in that room, it would turn on the boiler. Now, in terms of the install, you're like, oh my gosh, wired, this is totally a pain in the neck, right? Well, if you're installing the heat pump, you're already running wiring and line set and everything else from the outdoor unit to the indoor unit. Just run thermostat wire along with it. Put the relay kit in right at the start, right by the unit, make that a short little run, and then run thermostat wire down to the outdoor unit. And then you've got to go inside, you know, from the basement to get to the panel. That's where in a lot of cases you would just run your thermostat wire for whatever zones are being managed, and just label your wiring and plug them into your zones down there. That way you're not really interrupting any additional, you know, walls or trying to run thermostat wire in weird chases around the house. You're just using the existing work that you're already doing to accomplish this. So then it's very simple controls. It's all in one place. There's no Wi-Fi interaction whatsoever. And you get, at least in New York State, thousands of dollars, potentially thousands of dollars to support the amount of labor that would be involved in including a couple of thin wires with your existing installation. And as I mentioned earlier, it's applicable for most Mitsubishi equipment, right? So the FS are our deluxe hyperheat products. Our MLZs are the one-way sealing cassettes, SLZs, four-way sealing cassettes, the floor models. All of our ducted models have CN24. In fact, all of our ducted models have two CN24s, CN24 1 and 2, so you can have two stages of backup heat if you really wanted. And every single one of our P-series indoor units has it. What's glaring missing from this list? It's the GLs. So our GL wall-mounted units do not have a CN24 port or ability to set it up. So if you were going to use this strategy for integrated controls and you had a multi-zone system or, you know, one-to-ones, you would not use GLs. Now, next year, June 2022, we're going to have the release of the replacement for the GLs, the GS series, which will come in cooling only, standard heat pump, but also a hyperheat model. Those will have this same CN24 relay in it. So we've got this 8-month period where the GL or, you know, premier style indoor unit won't have that CN24 capability. Okay, great. And so just taking a little bit closer look at how on the wall mount units or on the units that have remote controls, how you would set this up. So this doesn't apply to the ducted systems, but on the ductless units, the sealing cassettes or the KJ or the FS wall mount unit, there's sort of like a secret push a bunch of buttons on the remote in order to adjust and set up the CN24 relay capabilities. All the capabilities are already built in to the ducted units and the P series, and so you can configure them separately. You know, and they already have some of those basic. They would turn on right out of the box. You know, you can adjust the settings, but they have default. With the KJ and the FS, you have to initiate it using the IR remote control in order to set it up. And I probably should. This slide kind of goes with the next slide. So the next slide here, and I'll go back and forth a little bit on these. This is a picture from, again, another app note off of my link drive that describes how to engage this and to adjust the factors. And the factors that you're adjusting are 2-point temperatures. One is the backup heat engaged temperature. So below this temperature, the heat pump can call for backup heat anytime it wants. And above the backup heat lockout temperature, only the heat pump will operate. So you might be like, there's no way on earth that I want my backup heat source to come on when it's above 50 degrees Fahrenheit or 40 degrees, whatever, you know, set point. You could make it, you know, fit. It doesn't really matter at that point, but like whatever temperature you're like, I definitely only want to rely on my heat pump above this temperature. You know, there's absolutely no reason that a boiler would ever come up at that temperature. That would be your lockout temperature. And then your backup heat engaged temperature would be, you know, some temperature below that. I mean, the heat pump's going to continue to operate through the entire range. It's only going to call for the backup heat below that temperature when there's absolutely a need and you're exceeding your droop. Okay. So that's the CN24 solution, and turning it on. Again, all the details are on my link drive, and I'd be happy to point those out to anybody that you know, the CN24 relays are in the controls page. If you scroll all the way to the bottom, that's where you'll see the CN24 relay along with a bunch of other components. And it's got a complete submittal and instructions on installation, and it also goes through, you know, the particulars of how it turns on and turns off, all that sort of jazz. So AirZone, next solution. AirZone, you can see on this picture, this is sort of like what I imagine is sort of like the anticipated primary way that AirZone is used for Mitsubishi equipment. In practice, I've actually seen, you know, more complicated systems of this is generally in practice. You have a AirZone control board that plugs in from our communication board to the CN105 port on any indoor unit. Here it's depicted connecting to an SVZ air handler. Then dangling off of the MA 2-wire connector is a PAR 40. You're going to want to use a Mitsubishi controller to commission the system before turning on the AirZone, just to make sure there's no errors. And if you have to adjust any of the functions like static pressure, you need to have a Mitsubishi controller in order to adjust that. None of that functionality is incorporated into the AirZone tech. Okay, and then from the AirZone, there are 3 connectors on the top. They're all really one and the same. There's 3 of them just for convenience of connecting multiple wires, but they're all one and the same, part of the same daisy chain wiring. And so then you run 4-strand shielded wire to all of the modules, whether they're ducted or other types of modules. It's just a daisy chain of communication. And the system is smart enough to know what each one of these components is. And you just, in the course of commissioning, you define what zone number each one of these are. And from those modules, you connect the thermostat. You have to have at least one wired thermostat. I actually recommend using all wired thermostats. They're touchscreen, they're a delight to work with. By having all of them be uniform, touchscreen wired, it's much easier for consumers and you get better control. It's already a high price system, so the incremental cost of going to the touchscreen wired is really pretty small. They do have wireless ones, but my experience is it just creates a little bit of confusion because they're not touchscreen. Okay, so and then you have your standard connector cables from your outdoor unit to your indoor unit. Okay, so there's your quick synopsis of AirZone. A little bit closer picture of the control board. Here are those daisy chain connectors. It comes with a 110 plug, so you got to park it or have an outlet near wherever you're going to have this parked. Typically, it's in the same space as the air handler. Here's your CN105 connector plugging into the Mitsubishi communicator card that plugs onto the standard AirZone card. That's you know, just kind of demystifying it. There are a couple of auxiliary stages right here, but those are really just auxiliary backup for like, you know, like if the whole system was experiencing a droop, you'd use those. But if you're using with an air handler, you could just use the CN24 relays off of the air handler in order to activate hydronic heat or something else. AirZone, if you're using motorized dampers, you cannot use an electric heat kit. It doesn't have sensors to ensure that there's sufficient airflow to prevent a total meltdown. So you cannot use electric heat kit with AirZone dampers. On the individual modules for the zones, there are these connectors. The one with 5 connectors, this is the daisy chain. You can see there's 2 sets of wires coming in here as part of that daisy chain. They all just get wired together. And then right next to it, these 4 connectors, the plus, minus, W, and Y. This is the set of wires that would go to your wired thermostat, your blue face thermostat. So then this is sort of the key component for integrated controls as it works with AirZone is this 5-port, 5-relay module. So this connects to the daisy chain. and then it has a whole series of relays. One, so it's in pairs. So the first two ports are relay 1, zone 1, second two pairs, zone 2, zone 3, zone 4, zone 5. And there's a dip switch in here that if you switch it up, it turns this into zone 6, zone 7, zone 8, zone 9, zone 10. So if you had an air zone system that had 10 ductless systems, or some number of ductless systems and some radiant or whatever else, but then on top of that you had backup zones for any one of those particular zones, you would wire them to the corresponding ports on this relay module. And then within the control structure, you can say, hey, use the heat pump, and here's my secondary. You turn on radiant heat zone, whatever, 3. And it's able to do all of that. Now, and it is possible through a third party to buy a Wi-Fi card that plugs into this to enable you to do it all online. So that's an option. And because you can do 10 zones with one thing, and all that interact both ductless and conventional heating systems or gas fireplaces or whatever you want, tremendous amount of flexibility, but it's a pretty expensive option. Some number of thousands of dollars of controls for most projects. Okay, just a couple of little things. The communication wire that's used for both the daisy chain and for the thermostats, the blue face wired thermostats, is this 20 gauge 4-strand that's shielded. You can purchase it directly through any one of our fine distributor partners. And on the slide deck, here's all the list of parts for the air zone, for ordering it. I will be, I am recording this webinar, and I hope to distribute it. All this information is available in the accessories section on our famous website, mylinkdrive.com. It's not in controls. This whole suite of products is considered an accessory. So if you go into the accessories tab and you scroll down to ducted accessories, air zone fits into that category because people anticipate it being used for its motorized dampers, even though in practice, I've seen plenty of installations that don't have any dampers, but they use air zone throughout because of the sophistication of the level of control and the touch screen thermostats. Okay, that brings us to IFTTT integration. IFT, you would need to have a Kumo adapter for each one of the indoor units that you aim to control. So the homeowner would have a Kumo account, and they would have the control on their phone, and within the Kumo application, they would link it to an IFTT Pro account, which costs, a couple bucks, $4 a month, something along those lines, in order to maintain. So there's an ongoing subscription cost associated with it. But if somebody was like, I've got Internet of Things throughout my entire house, and I'm controlling it all through IFT, and and I want to have the Kumo part of it, we can definitely do that. And it qualifies as a method of providing integrated controls for programs both in Massachusetts and New York and elsewhere. So applets are the little subroutines that you build or select on the IFT site in order to manipulate the controls of the thermostat, the conventional heating system, and the heat pump. Of course, we don't have control over IFT, so any of these things, the fee per month, the way that people interact with it, that's all sort of independent of us at Mitsubishi. And while we can provide some level of support related to Kumo Cloud's interaction with IFT, we wouldn't be able to really provide that much support for other associated devices and applets that are connected to the entire system. So just be mindful of that. That's why I say, if you guys were like, I love IFT and I want to give it to all my clients, okay, boy, that is a mission that you're on. Generally, I would say this is going to be something for clients who are already into a whole home, smart home integrated controls approach and are already familiar with this technology. Okay, and like there's additional information here. Some of these slides were provided to me by our esteemed and highly capable controls group. David Bourbon has spent a fair amount of time looking at all of this interaction with IFTT and setting up Kumo adapters and Kumo apps so that it could interact with it with the rest of the team. So there are there's some ability to customize applets within IFTT, but there are also sort of standard applets that can be just selected and incorporated into your system. And applet is really just sort of like a little subroutine that communicates with the different devices. Okay, so the last option here, finally, right? You guys are like, oh my God, so much integrated controls. The last one here that I'm mentioning is the third-party integration with Flare. It's only compatible with Ecobee and Honeywell smart thermostats if you're going to interact with them. And it communicates directly using IR to our devices. So one of the things to understand about that is that it has to be in a direct line of sight of the indoor unit, right? Which isn't too complicated when you're talking about a wall mount or a floor mount or something like that, or even a ceiling mount, but it has to be in direct line of sight. And the other thing is, I mean, like, if it's a unit, an indoor unit that does not have a remote with it, you may need to add an IR receiver. So if you had, for instance, a square ceiling cassette that does not come with a remote or an IR sensor, you would have to buy an optional IR receiver in order for, you know, the flare to communicate with it. Same would be true for any of our ducted units or any of our P series products. Okay, so it works. You know, we're confident that it works, and you know, they say it works with a lot of different devices and can identify different communications of different manufacturers, whatever. I think it works. We haven't sat down and tested it with all of our products, but we have no reason to believe that it wouldn't. But it's also true that we are not really geared to provide customer support for the installation or troubleshooting of the system. Just be mindful of that. Okay. And I'm not exactly sure where the website is to find all the information on Flare. I'm sure that you could Google it and find any necessary information that on the installation and setup. I'll leave it up to your capable hands and minds to do that. So let's move on to some application discussion. And here, like, is one of the examples that I like to refer to just to kind of give you an idea of what can go wrong in different scenarios. And one of the reasons why I'm a big proponent of using a droop only strategy and not encouraging the use of any cutover temperature whatsoever. And if you're using the Kumo station, for instance, where you have that capability to set a cutover temperature or switch over temperature, I recommend changing it to never and just allow the heat pump to continue to operate through the system through the season and bring on additional heat thereafter. So here's a house in Massachusetts. We ended up doing a site visit to this one to kind of try and figure out what the heck was going on. The owner of the house, who was a tenant living there, was complaining that, you know, broadly and widely that heat pumps don't work at colder temperatures. But the reason why it wasn't working is because the system was configured to shut off 4 of 8 zones of 3 multi-zone outdoor units anytime it dropped below 30 degrees Fahrenheit. And so it was complete, you know, I mean, the installer was completely just following the guidance of the program in Massachusetts in order to accomplish this. No harm, no foul. The system was immaculately well installed. There's really no problems with the installation whatsoever. But inside of the controls, they followed guidance and set a switchover temperature at 30 degrees. So anytime it would drop below 30 degrees, like into the 20s, like it does, even in Massachusetts, right? Suddenly, 4 of the zones that correspond to these 4 parts of the house shown in gold, and really, like, this house was actually like 3 structures that were connected with indoor breezeways, is the best way to describe it. And so each one of these 3 parts of the house, which combined totaled like something like 3,400 square feet. These multi-zones correspond to each one of those 3 boxes, and the hydronic zones fed off an oil boiler corresponded to each one of those 3 structures. And basically, the multi-zones, one of the things that was kind of wacky about it is that, at 30 degrees, it would shut off and turn on the hydronic zone, but it would turn off, one of, or in some cases, half of the indoor capacity of the outdoor multi-zone system. And so the multi-zone is like, well, one of my indoor units wants to keep running and hard, but the other one's totally off. And so there's a mismatch between the indoor and outdoor coil size and the capacity of the compressor. And so it would generate a fair amount of cycling. And then on top of that, the radiant would come on, but in 2 of these zones, it was baseboard, and in 2 of the zones, it was underfloor stapled. And if there's anything we know about underfloor staple, it takes a long time to heat up the floor to a point where it would be able to deliver heat into the space. Depending on the circumstances, it could be a day or more. So anytime it would drop below 30 degrees, the key heat pumps zones would shut off, the radiant would turn on, the homeowner would get very cold, and so as a practice, or the tenant would get very cold, and so in practice, the tenant would march around the house with a space heater and plug it in wherever she was hanging out. And so the consequence was the heat pumps were cycling, using more electricity and being less efficient. She was adding a lot of electricity use by using a space heater anytime it was in the 20s or below. They were also using a fair amount of oil because there was cycling going on. Like the boiler would come up and maintain temperature and then shut off and try and heat zones. And it was just all over the place. And so at the end of the year, it's like, the owner's like, I thought I was going to save a lot of money by putting in a heat pump system and getting as efficient as I can, but I actually spent way more in energy costs, and it wasn't able to work at cold temperatures. And my client, my tenant was really uncomfortable. And so, like, how do you fix this? Well, honestly, the fix was really just going into the settings and changing it so there was no switchover temperature. That would just never run, because the combination of those 3 multi-zones puts out like 95,000 BTUs at 5 degrees Fahrenheit, consistent with what the load of the house is. It was sized to 100%. And so the frequency that the boiler will need to come on going forward will be basically never. And the consumer will see that the heat pumps will operate through the entire season and maintain consistent heat throughout, and augmented heat will come on only when absolutely necessary. And we'll see. I'm sure that I'm going to hear from the owner next spring. We'll find out exactly how that turns out, but that's the fix. So kind of coming down in closing, when we're talking about what are the things that we need to think about with applications, you need to look at the correlation between zones. What is covered by the ductless zones? What is covered by the conventional heating zones? Which ductless zone is going to be controlling whether or not this zone turns on. So if you have a conventional zone that covers an entire floor, but you have 3 ductless zones in that same floor, like a second floor, which one of those 3 zones is going to be the one that you're going to make turn on that conventional heating system? What is the mechanism or the sensing point for controlling those 2 zones? So that's one thing that you need to keep in mind. Another, like a worst case scenario that we've seen in some circumstances where somebody's like, well, I want the incentive for integrated controls, and this wouldn't really happen in New York, but like, oh, I'm going to put a heat pump up in my bedroom, and the integrated controls control the heat throughout the rest of the house. Well, that's not going to work so well. They may have only wanted the ductless in their bedroom, but it's inappropriate to connect that to the zones for the entire house, because when they adjust the temperature in the bedroom, that's not going to necessarily deliver heat to the rest of the house. So most of the season, it's just not going to work. And then when the bedroom's unable to keep up, it's not necessarily going to sense temperature appropriately for the rest of the house. So that's like a total disaster situation. But that gets to the point of like, you got to make sure there's correlation between the zones of conventional for your backup and your indoor units. And you may have to think outside of the box in order to do that, either like setting up a separate control that manages things separately, or just selecting one of these 4 or 5 options that makes the most sense for that particular application. Okay, and then the last point on this page, it really is important to know where you're sensing temperature from. And so I would recommend anytime that you're using a ductless, like a wall mount unit or a ceiling cassette or something like that, that you either use a wireless remote, like one of those little humidity and temperature sensors, or you use a true thermostat, one of our Mitsubishi thermostats, or a third party with a third party thermostat interface. But it's really important that you select a location for your thermostat or your sensing place that's going to be able to serve both distribution styles of both your conventional and your ductless heat pump system. The cheapest and simplest way to accomplish integrated controls is probably the CN24 relay kit. A lot of guys don't gravitate towards that because it's, it seems like running wires is troublesome or whatever, but it's pretty bulletproof and low tech. The Kumo station has been used extensively in Massachusetts. There's hundreds upon hundreds of these systems out there, and people have gotten pretty good at using them. It's pretty nice to be able to manipulate all the controls on your phone. It's a good client feature, and if you're sizing the system to 100%, the frequency that it's going to turn on the backup is pretty low, and so people get an additional benefit that's paid for through the New York program to have integrated controls and manipulate that. You do have the ability to set a switchover temperature in Kumo station, but my recommendation is to set that to never and always have the heat pump in operation. Don't be swayed by economic balance point. It's just not that great. You can actually contribute to worse efficiency depending on how the settings are relative to that house. If you need something really more sophisticated, high-end home, they're looking for the premium product that has touchscreen capabilities, possibly Wi-Fi, many zones, many different styles of heating systems. Arizona can accomplish things that no other controller from any other manufacturer can, as far as I know. And then, of course, there's third-party thermostat interfaces, which can make for a very simple interaction for the consumer. And the last option, or well, 2 other options, of course, the IFTT using the Kumo adapter for smart homes and super geeky homeowners. And then the last one, of course, is a third-party option. And I'm sure there are other IR solutions as well, but the Flare Puck Pro is identified as one of the solutions that meets the standards for both Massachusetts and for New York, and probably other programs as well. So those are sort of your key options when you're considering how to do integrated controls anywhere in the country. I will be circulating this, as I mentioned. Most of these resources are all on mylinkdrive.com. If you're not familiar with this website, I recommend grabbing a cup of coffee or a beer and spending some time there and just parading through. I really think of it as sort of like a library. And much like a library is organized in such a way that once you understand the system, you can go and you can find everything. My link drive is very much like that. So once you, and not just like for the individual pages. So if you go to one indoor unit or you go to another indoor unit, the layout will be the same. The way that the documents are listed, from install manuals to service manuals to parts manuals to submittals, is all in the same sequence. But those individual documents, the submittals for every single document for every product looks the same. The sequence of information in the install manuals is all the same. So if you're like, I need to know where the electrical diagram is on this indoor unit, if you can find that indoor unit on the website, which won't be difficult, you can go almost to the exact same section in that installation manual and find the information you're looking for. So once you understand the format of the library at My Link Drive, all the information that is available to our customer care service providers that, you know, are able to pretty much nail any problem that people call on, is right there at your fingertips, an incredibly powerful tool. And so I highly recommend just increasing your familiarity with mylinkdrive.com. And so thank you so much for joining me on this webinar. I'm open to answering some questions if anybody has some. I'll turn off this slide deck. Feel free to contact me via email or phone for questions. I'll try to get back to you as quickly as I can. I'm a pretty busy guy, but I definitely want to help you understand any aspect of this or any other part of Mitsubishi's programs or opportunities. And so with that, I will stop sharing. And if there are any questions, let's see, I've got one in the chat box. Are we confident that the existing grid can handle the increase in load when switching from fossil fuel to all electric? Yes. Yes, we're quite confident of that. And I'm resoundingly confident in that for a number of different reasons. The number one reason is, of course, that there are whole slews of people that their job is to monitor the grid and to look at it far out into the future as to what the capacity needs are. And there's plenty of time to respond. Particularly where heat pumps are involved, the install rate in any of these states, and of course, Vermont and Maine are the fastest in terms of install rate per capita. You can see this train coming from 100 million miles away. They're going to be able to respond to this and add the additional capacity or batteries or whatever is required in order to deliver the electricity that's needed for these different heat pumps. If systems are appropriately sized so that they can deliver heat all the way down to super cold temperatures, there won't be any need for backup heat. Places like Texas, where there's a high amount of electric resistance heat, if they switched over to heat pumps, they wouldn't have had any of the problems that they had last winter, or significantly so. I mean, you can't really help them for the generators, but that's sort of the main deal. So let's see, another question. I'll get off of that one, that little soapbox. How many indoor units can I use with the Kumo cloud? I believe it's up to 16 indoor units can connect to Kumo cloud in a single location. And then, you know, I mean, the Kumo station has 4 dry contact relays, so you'd have to select which ones were indicating the control over backup heating zones. Have you seen any issues? Next question is, have you seen any issues with going all heat pump when used with whole house generators? You know, like any circumstance, you're going to have to look at the load of the rest of the building as well as what the heat pump requires. Even our largest heat pumps, the largest ones that we have, the 8C48 or the 8C60, you know, the top draw that I've seen out of those systems is generally like in the 7,000 watts category in their most energy demanding portion of their cycle, a defrost or, you know, a high throw. And so as long as you have a whole home generator that can manage that kind of a load, it's not a problem. For smaller units, like, you know, a 9,000 BTU unit, the load, even in the coldest part of winter, is less than 2,000 watts. And so you could have perfect comfort that a smaller generator would be able to satisfy the needs of that heat pump quite well. And in fact, heat pumps are totally gentle on generators because they start up relatively slow. You know, conventional heating systems with like a boiler blower, you know, motor that kicks on, that's pretty tough on generators, but heat pumps ramp up much slower. And so, and in terms of the cleanliness of electricity, if it's even remotely decent filter on the generator, it's going to be just fine. When the power goes into our Mitsubishi equipment, one of the first stops it makes is to a power board that converts, cleans, smooths the power. So it really is designed to handle a wide range of different voltages and has some flexibility in that. Okay, so let's see. Next question I have is, yeah, dirty electric signal. You know, if it's unless it's the worst generator ever, it's going to be just just fine. Most generators that you'd buy off the shelf have more than a clean enough power signal in order to power heat pumps with no problem. Question from Kevin. Do you think that backup fossils are even needed? SVZ with an electric strip should be all the backup you need in that application, correct? Yes, and in fact, you know, I totally agree with you. If you're replacing a furnace and you're putting in an SVZ and you're appropriately sizing it and you just want to have the belt and suspenders approach, you can put in an optional heat kit just to absolutely make sure that under no circumstances, even if there's a communication error with the heat pump and it's not operating, that they would still have heat throughout the house. So, and of course, I think that that would qualify as a decommissioning of the system in New York State. But that's definitely, that, you know, that would qualify as integrated controls in most other places. William asks, should we be recommending surge protection and phase protection equipment for such equipment? Are there reference studies to show consumers build confidence going all heat pump? Okay, so the first part of that, surge protection, you know, it really depends on the locality as to how important surge protection is. If you're in a part of the world where there's frequent power outages or fluctuations, you're at the end of a long line, often a rural area, it may be appropriate to have surge protection added into the panel. It's really not that costly, but it isn't really something that is included in most installations, and it doesn't really appear to be a problem not to have surge protection. Is there a greater risk of having a problem with electronics? Just like every other piece of electronics in your house for surges or lightning strikes or something like that. Of course, if you put in surge protection, that's not 100% guarantee that you wouldn't have a problem if there was something serious like a lightning strike either. Okay. Are there reference studies to show confidence building in going all heat pumps? I think really this question gets to the phenomenon that we're seeing in the growth in the marketplace for heat pumps. In places where there's been higher penetration in New England, like Maine, like Vermont, there's much greater confidence and acceptance of heat pumps as an all-in solution or as a substantial solution. And I think it takes a while for that public confidence to build, and part of that has to come from the programs to communicate that to the public. It's not just from contractors and manufacturers, although, you know, we're trying to get that message out. And so, you know, it's okay. I think it's perfectly acceptable to use this sort of like, well, if you're worried about it, we'll hook up backup heat. You can keep your conventional heating system. But as some folks on this call I know can attest, after a couple of years of not using your backup heating system at all, you start looking at it and be like, boy, I could sure use that extra space in my basement. And so it's sort of a transition thing. You can say, well, we'll hook this up with backup heat. And then at some point in time, after you've realized that you really don't need it, you can deal with that later. And that gives people the satisfaction or the comfort that they need to sleep through the night, not worrying in those initial phases until they get used to using heat pumps. And then of course, they'll tell all their friends, family, and neighbors that they don't actually use any backup heat. Okay, so let's see. Some of the concerns we hear from our contractors are from a service standpoint, that if the system goes down in the extreme temperatures in the winter, working on a refrigerant circuit and cold weather charging instead of working on furnace or boiler, the envelope. Yeah, so I hear you. And that's why, so the question is really about, you know, reliability in the middle of the winter and being able to service them when it's particularly cold outside. You know, it was back the end of 2017, beginning of 2018, when the polar vortex came through New England in a big way. And it's been a few years back, but that 2-week period was, you know, the coldest by a long shot in a very long time. And during that time, I was traveling around Maine and New Hampshire visiting distributors and installers, and everybody was like working 24/7. Probably a lot of people on this call remember that, and we're working 24/7. And I'd ask them and say, well, what are you doing? Oh, well, it's all no heat calls, or, you know, not enough heat coming out of boilers, blah, 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 blah. I said, well, you know, are you having any problems with heat pumps? And it was like crickets. I mean, like, this is the coldest period of time, and nobody was having any problems or concerns or issues with heat pumps at all. And every winter since then, I still am not getting any phone calls in the dead of winter for problems on these systems. If you really do have an emergency circumstance, you do the same thing you resort to for any conventional system where you don't have heat. You bring in supplemental for a brief period of time until it takes you to get the parts or make repairs or something like that. All that being said, Mitsubishi is working hard to increase the availability of parts that would be, so there's less of a delay, or it's readily available in the area. We're working with our distributors to try and make sure that we have a lot of stock of parts, considering the fact that it's being used more and more as the primary heat source. The second part of that is that I encourage that when you're doing an installation, when you're looking at a project where they're going to be using heat pumps, or their intention is to use heat pumps as their primary source of heat, I recommend offering an option with multiple condensers. And so that way, if there were ever a problem with one condenser, you would still have the other condenser running. I mean, this is 2021, people. We don't really need to have emergency heat calls. Let's just figure out a solution. And honestly, 2 smaller condensers are roughly the same price as 1 larger condenser. So the equipment cost really doesn't change. There's a little bit of extra electrical work, right? You're gonna have extra breaker in the panel and electrical run, that sort of thing. But if somebody's going down this road, giving them the peace of mind of having some extra redundancy and eliminating the need for emergency calls can give everybody a little bit of a relief. Okay, so then looks like that might be the last question that's posted to the chat. If anybody has any other questions, that's great. Okay, so I'm going to stop the recording at this point in time. I greatly appreciate everybody joining me for the call this morning. I hope that this was informative and helps you figure out the best way to accomplish these for various programs and opportunities with your clients. Thank you for your loyalty in choosing Mitsubishi. If there's anything that I or any of the area managers or Mitsubishi team can do to assist you with your clients and your projects, please let us know. Again, thank you and have a fantastic weekend.